Hello everyone, I welcome you all in today's lecture. The today's lecture is on the expert system. So in this lecture we'll see what is expert system, what about the architecture of the expert system, what are the advantages, limitations and the applications of the expert system. So first of all, what is an expert? The definition of expert is that an expert is someone who have reliable source of knowledge or skills and have extended or strong experience through practice and education in a particular domain. In other words, we can say that the expert is nothing but who have the deep knowledge in a particular domain. So we can consider different examples of the experts are doctor, teacher, chess player, car mechanic, surgeon, shepherd, solicitor. So all these experts who have the deep knowledge in their particular domain. What is expert system? In artificial intelligence, an expert system is a computer system that emulates the decision making ability of a human expert. The first expert systems were created in 1970s and then proliferated in the 1980s. So expert system, in other words, we can say that it is equal to knowledge plus problem solving methods. There are many expert systems which are already designed. For example, medical diagnosis. It is designed to diagnose human illness. Then financial forecasts, schedule routes for delivery vehicles, play chess, configure computers, monitor real-time systems, make a financial planning decisions, etc. What is knowledge? The data is collection of facts and the information is organized as data and facts about the task domain. So data, information and past experience that can be combined together and that terms as a knowledge. So anyone can be considered a domain expert if he or she has deep knowledge of both facts as well as rules and strong practical experience in a particular domain, and the area of this domain may be limited. In general, an expert is a skillful person who can do things other people cannot. The human mental process is internal and it is too complex to be represented as an algorithm. So, however, most experts who are capable of expressing their knowledge in the form of rules for the problem solving. So, we'll see one example of rule based problem solving. If the traffic light is green, then the action is go. If the traffic light is red, then the action is stop. This example is considered of signal system. How we can define the rules as a representation, knowledge representation technique. The term rule in artificial intelligence, which is the most commonly used types of knowledge representation, and it can be defined as if then structure, that is very well known by us, and which are relates given information or the facts in the if part to some action in the then part. A rule that provides some description of how to solve a problem. So rules are relatively easy to create and understand. The rules can be represent relations, recommendations, directives, strategies, and heuristics. So we'll see here the example for each rule, how the rules can be represented in the form of relations, recommendations, then directives, strategies, and the heuristics. The first example for the relations. If the fuel tank is empty, then the car is dead. The simple rule is defined. So condition is there. If fuel tank is empty, then car is dead. Then action is what? Car is dead. The second, recommendations. In this, if the season is autumn and the sky is cloudy, and the forecast is drizzle, then the advice is take an umbrella. So recommendation is here, more than one rules are added here we using the and connectives, and if this condition is satisfied then it recommend that yes you can take an umbrella. Then directives: if the car is dead and the fuel tank is empty, then the action is refuel the car. So if the car is dead, that is the rule, and the fuel tank is also empty, so whatever another condition which is also satisfied, then the action is that refuel the car. That is the example of the directives. So it gives the direction. Then strategies: if the car is dead, then the action is check the fuel tank. Step 1 is complete, right? If step 1 is complete and the fuel tank is full, okay, step 1 is what it suggests ki yes you can check the fuel tank, right? And then after checking the fuel tank, then it says yes fuel tank is full, and if that condition is satisfied, if the if fuel tank is full, then what will be the next step? So then the action is that check the battery, that is the step 2 is complete. So in this way the different strategies we can apply. Then heuristics: if the spill is liquid and the spill pH is less than 6 and the spill smell is vinegar, then the spill material is acetic acid. So whatever the knowledge is given in if part, so based on that if part knowledge, it can guess that it can, we can say that give the knowledge that is what that spill material is the acetic acid. There are different characteristics of the expert system. So before going to see architecture of the expert system, we'll see different characteristics. The first one is that high performance. They should perform at the level of human experts, because what are the experts whose knowledge is applied while building the expert system. Then adequate response time. They should have the ability to respond in a sensible amount of time. So whatever that action, it should be taken within the time, within the sensible amount of time, we can say that. Reliability: they must be reliable in a nature and should not collide. Understandable: they should be able to make reasoning from the knowledge. Yes, whatever the knowledge is available, from that knowledge it should take the decision, it should be able to take the decision, that is nothing but the understandable. What are the capabilities and incapabilities of the expert system? So what expert system can do and what expert system can't do. So capable, the capabilities of the expert systems are yes advising, then instructing and assisting human in decision making, then demonstrating, deriving a solution, diagnosing, explaining, interpreting input, predicting results, justifying the conclusion, suggesting alternatives options to a problem. And what expert system can't do? Yes, substituting human decision makers, possessing human capabilities, then producing accurate output for inadequate knowledge base, and refining their own knowledge component. Now we'll see architecture of the expert system, in which there are different components of the expert systems are mentioned. The first one, user interface, then knowledge base and inference engine. So in the diagram you can see the user interface, then knowledge base and the inference engine is given. Now all these components we'll explain in detail in the coming slides. You can see in the diagram human expert is there. For example, the doctor who are expert in particular diagnosis, for example heart diagnosis, lungs diagnosis or any other. Then knowledge engineer that use the knowledge from the expert system. It collects the knowledge from the human expert, from the doctor in different ways, and that knowledge actually is organized or stored into the knowledge base. An inference engine is used to derive the new knowledge from the knowledge base, and then it provides that knowledge to the user interface, that is with the users. Then user can easily use that knowledge, and that user may not be an expert. Now we'll see all these components in detail. The first component is that knowledge base. So it contains domain specific and high quality knowledge. So knowledge is required to exhibit intelligence. The success of any expert system majorly depends upon the collection of highly accurate and precise knowledge. So knowledge base is very important component of this expert system. So correct or accurate information and information available in large space should be important. So based on that information, the accurate decision will be taken. So components of the knowledge base. The knowledge base of an expert system is a store of both actual, factual and the heuristic knowledge. So factual, it is the information widely accepted by the knowledge engineer and scholar in the task domain. Heuristic knowledge, it is about the practice, accurate judgments, and one's ability of evaluation and guessing. Now, how to represent this knowledge? As we have seen, the if then rules are used to represent the knowledge. So it is the method used to organize and formalize the knowledge in the knowledge base. So it is in the form of if then else rules. Knowledge acquisition. The success of any expert system majorly depends upon the quality, completeness, and accuracy of the information that is stored in the knowledge base. Of course, the knowledge base is formed by the readings from various experts, scholars, and the knowledge engineers. And the knowledge engineers, what is the role of the knowledge engineers? It is the knowledge engineer is nothing but the person with the qualities of empathy, then quick learning, and case analyzing skills. He acquires the information from the subject experts by recording, interviewing, and observing him at work, etc. He then categorizes and organizes this information in a meaningful way in the form of if then else rules, and that is to be used by the inference machine, inference engine, and the knowledge engineer also monitors the development of the expert system. Now, inference engine. Use of efficient procedures and rules by the inference engine is essential in detecting a correct and flawless solution. So in case of the knowledge based expert system, the inference engine acquires and manipulates the knowledge from the knowledge base to arrive at a particular solution. So in case of the rule based expert system, it applies the rules repeatedly to the facts and which are obtained from the earlier rule application. It adds the new knowledge into the knowledge base if required, and it resolves rules conflict when multiple rules are applicable to a particular case. To recommend a solution, the inference engine uses the following strategies: forward chaining and backward chaining. So what is the forward chaining? It is very simple. It starts from the initial state and lead towards the goal state. It is a strategy of expert system to answer the question, so what can happen the next? So here the inference engine follows the chain of conditions and derivations and finally deduces the outcome. It considers all the facts and the rules and sorts them before concluding to a solution. So this strategy is followed for working on conclusion, results, or the effects. For example, the prediction of share market status as an effect of changes in the interest rates. So in the diagram we can see there are different facts, fact 1 and fact 2, that can be combined, and then it deduces the one decision, that is decision 1. Fact 3, fact 4, okay, it consider either fact 3 or fact 4 and it conclude the decision number 2, and then this decision 1 and decision 2 in combine, and that gives the decision number 4, for example. So in this way the forward chaining take place. So from the available knowledge or the facts, the decision is taken, and from the available decisions again it takes the decision. and it try to leads to the goal state. Now backward chaining, so it is completely reverse to the forward chaining. So from the decisions from the goal state, it try to conclude or they derive the facts. With this strategy, an expert system find out the answers to the question why this happened on the basis of what has already happened, and the inference engine tries to find out which condition could have happened in the past for the result. So this strategy is followed for finding out the cause or the reason. For example, diagnosis of blood cancer in humans. For example, diagnosis of the blood cancer in humans. So what are the reasons or the what you can say causes? So because of that, the blood cancer is there. So what are the then symptoms of any disease? So what are the different symptoms? These are nothing but the facts, some few symptoms which are given, and from that symptoms it derive the what will be the disease. So this is simply forward chaining. And in backward chaining, disease is there, and from why actually this disease, why actually this disease is there, and what are the reasons to, just because of that reasons this disease is there. So it try to find out the facts. So that is the backward chaining. User interface, this is the final components of the expert system. It provides the interaction between the users of the expert system and the expert system itself. It is generally natural language processing so as to be used by the users who is well versed in the task domain. Because why actually it is used the natural language processing? The user can ask the questions in their own language, native language, and expert system should be able to answer it whatever the language is there. That's why natural language processing is there, because expert system is don't have the knowledge about the in what form actually he or she should ask the question. So he or she can ask the question in any way in any language. And user interface, it means that the expert system should be able to understand the questions and give the answer for that respective questions. So the user of the expert system need not be necessarily an expert in artificial intelligence. So it explains how the expert system has arrived at a particular recommendation, and the explanation may appear in the following form. So natural language displayed on a screen, verbal narration in natural language, listing of rules numbers display on the screen. Then the user interface makes it easy to trace the credibility of the deductions. It should help users to accomplish their goals in shortest possible way. It should be designed to work for users existing or desired work practices. So its technology should be adaptable to users requirement and not the other way round. So it should make efficient use of user input. So what are the limitations of the expert system? So no technology can offer easy and complete the solution. So large systems are costly, require significant development time and computer resources. So expert systems have their limitations, which includes that is limitations of the technology, then difficult knowledge acquisition. Expert systems are difficult to maintain, and high development cost. Example of the expert system dialogues is given. The questions: do you know to which restaurants you want to go? The user can answer no. Is there any kind of food they would particularly like? Answer is no. Do you like spicy food? Answer is no. Do you usually drink wine with meals? Answer is yes. When you drink wine, is it French wine? Yes. Do you prefer red wines? Yes. So the question asked depend on the previous response given, and the user is working through a tree of possibilities. So whatever the questions initially asked and what the answer is given by the customer or the user, and based on that it frames the next questions. So it should not be in the questions which are asked in a sequence. The questions can be different. It is depend on what actually answers is given in the previous question. So based on that, the next question will be there. What are the applications of the expert system? In design domain, actually it is used. So camera lens design, automobile design, so where it can be used. Then medical domain, yes, it is very hot domain and where expert system can play the important roles. So diagnosis system to deduce the cause of disease from observed data. Then conduction medical operations on humans. Then monitoring systems, yes, comparing data continuously with observed system or with prescribed behavior such as leakage monitoring in a long petroleum pipeline. Process control systems, controlling a physical process based on monitoring. Knowledge domain, yes, is finding out the faults in a vehicles or the computers, that is computer troubleshooting problem. Then finance and commerce, detection of possible frauds, suspicious transactions, stock market trading, airline scheduling, cargo scheduling, where the expert systems can use. Thank you.